Hey guys, welcome to chapter 10 of the geometry program. And in this chapter, we're going to focus on three-dimensional figures. So we're going to be finding surface areas and volumes of three-dimensional figures, and we're going to need some formulas to help us. So without further ado, let's jump in. In order to find the surface area of a prism, we need actually two areas, and this helps us organize our information. So we need what's called the lateral area, or I'm going to abbreviate LA, and that is simply the perimeter of the base times the height. So you can see that over here in my figure. The purple here is outlining the perimeter of the base, and then the H, of course, is the height of the figure. And then we're going to use the lateral area here to find the surface area. So the surface area, then also abbreviated as A, is going to be the lateral area plus 2 times big B. Now keep this in mind. Students often confuse big B for little b. Big B is the area of the base, not just a side of the base of a shape. Okay, so I have that highlighted here in our picture. It's that area of that base. So, all right. Let's work on in a very simple example where the base of our shape is a square. So we need the lateral area, which is the perimeter times the height. Well, the perimeter is 5 plus 5 plus 5 plus 5, which is 20. And then times the height. The height here going in the opposite direction is going to be 8. And I multiply that together, I'm going to get 160 meters. Okay, that's not too bad. Now the surface area is the lateral area plus 2 times the area of the base. Well, we just found the lateral area, so that makes our life easy. Plus, we need 2 times the area of this base. So again, here is my base. We had found the perimeter of this base by adding it up, but in order to find the area of the base of a square, so the area of a square is like that side squared, right? So in our case, it's going to be 5 squared, which is 25. So the area of the base is 25, 5 times 5. So you're going to get 160 plus 2 times 25, which is 50, which is going to give you 210 meters squared. All right, not too bad. Let's jump to another one. All right, in this prism, so this is a triangular prism. It's a triangular prism because the base is a triangle. And sometimes the shapes tend to be a little bit, if you're not spatial, you struggle to identify what part of the base, what part of the shape is the base. And particularly for a prism, we can identify this when we see the same shape on both ends. So when you see the same shape on both ends, you can identify that as a base. So this is a triangular prism, but doesn't matter, we can use the same formulas. So first we need the lateral area, which is the perimeter times the height. All right, so I have 10 here as the hypotenuse of that triangle, so it also has to be the hypotenuse of this triangle. So my perimeter is going to be 6 plus 8 plus 10. And then the height is going in this opposite direction here, which happens to be also 10. Okay. So then we're going to get 14 and 10, which is 24 times 10, which is going to be 240 meters squared. All right, that's my lateral area. Now my surface area. So the surface area is going to be the lateral area plus 2 times the area of the base. My lateral area is 240 plus 2 times the area of the base. Now, here, again, let's just review. This is 6, 8, 10. This is my base. How do I find the area of this triangle? So the area of a triangle is 1/2 little b times h. So in this case, it's going to be 1/2 8 times 6, which is going to be 24. All right, so I'm going to plug that in. That's the area of the base of my prism. And now I'm going to keep solving. So 240 plus 48 is going to give me 288 meters squared. So this is going to start putting all of your geometry together, where we have to remember how to use areas of regular shapes, of polygons, and things like that. Like this one. So here we have a hexagonal prism. A hexagonal prism. Our bases are in the shape of a hexagon. So we're going to use what we were just practicing in the previous chapter, plus this new stuff. So the lateral area is the perimeter of the base times the height. All right, well, you can see I tried to highlight it here in purple that this is a regular hexagonal prism. So my side length is 11. In order for me to find the perimeter, then I need to take 11 times the number of sides I have. This is a hexagon, so I'm going to have 6 sides in my hexagon. And then I need to multiply times the height, which is going in the opposite direction, is 12. All right, so when I multiply that together, I'm going to get 792 meters squared. All right, now to find the surface area. The surface area is the lateral area plus 2 times the area of the base. All right, now my base is this hexagon. We just did this, where we know the apothem. So the area of the hexagon is going to be 1/2 perimeter times apothem. All right, so the perimeter, again, the side length was 11, so that would be 11 times 6. And then they give us the apothem, so that was very nice of them. All right, so if you multiply that together, then you're going to get 313.5. All right, now we have all of their information to put together. So the lateral area goes here. It's 792 plus 2 times the area of the base. The area of the base was this hexagon that we found the area using 1/2 perimeter times apothem, and we got 313.5. And now when I put this all together, I'm going to end up with 1419 meters squared, 1,419 meters squared. Okay, so these prism ones just take time and patience to identify what your bases are, be able to identify your side length, your height, and then based on the shape of that base, using the appropriate formula to find the area of that base in order to be able to plug it into the surface area formula. All right, the other type of shape that we're going to find the lateral and surface areas for is for a cylinder in this section. And again, we're going to have the lateral area and the surface area. These are actually a little bit simpler because in a cylinder, the bases are always the same, right? They're always this circle. So the lateral area is given by 2 pi RH, and you can see in my little diagram here that the height, of course, is this long edge, and then down here in our base, we have the radius. And then the surface area, again, is going to be the lateral area plus 2 times the area of the base. But for our purposes, the bases are always these circles, and the area of the circle is pi r squared. So it actually makes these replacements a lot easier, I think. So I'm just going to do one example for you here, because I think that you'll get this pretty easily. All right, so the lateral area is 2 pi RH. So for our purposes, it's 2 pi and r. Now, in my diagram, I actually gave you the diameter. So in order to get r, I have to take that in half and get 5, and then multiply times the height. When you do that, you're going to get 100 pi. And actually for these, I'm fine with you leaving your answers in terms of pi. If you need to check them, or maybe specifically on the quiz or test, if it asks you to round to the nearest tenth, then you can go ahead and multiply by the pi button. But as we move forward in mathematics, we're going to want less and less of these approximations using decimals, and we'd rather leave it in exact form. So I am perfectly content and I'm happy for you to leave it in terms of pi. All right, and now the surface area. The surface area is the lateral area. Okay. The lateral area plus 2 times the area of the base. So that's actually 100 pi plus 2, and then again, my base is pi r squared. So if we plug in, okay, plus 2 pi, and then my radius was 5 squared. Then I'm going to get 100 pi plus 25 pi, and that's going to give me 150 pi meters squared. Okay, so I'm fine with that. If they need an approximation and you multiply times the pi button, you're going to get 471.24 or something meters squared. But like I said, I'm fine if you leave it in terms of pi. Okay, so hopefully that was a sufficient explanation for you. When you're ready, finish up your notes, read through the examples, and begin your assignment.